Welcome everyone to the Full Spectrum series. My name is Nick Valentino. I am an assistant director in the Hajim School of Engineering and Applied Sciences Dean's Office, and I am your host for this series. This is the third year of the Full Spectrum series, where we invite guests to discuss and explain their fields in an effort to inform and educate prospective and current students, parents, and alums all on the problems that engineers and computer scientists are trying to solve. We have heard from professors and professionals so far in the Full Spectrum series, so we thought it would be beneficial to hear from another source, a graduate student, which is a great source of information. Our guest today is Reem Mislati. Reem earned her undergraduate degree in electrical and computer engineering from the University of Rochester in 2019. Reem conducted research in Dr. Marvin Doyley's lab and also served as a departmental peer advisor and teaching assistant. Reem, between being a successful undergraduate student, teaching assistant, researcher, you have done so much already. I can imagine that
I tried.
is all encompassing, so thank you for your time.
Of course.
So electrical and computer engineering is a very broad field. So we have some viewers who have no or little background on this. So can you give us an overview of electrical and computer engineering?
Yes, of course. So let me just share my screen with you. So electrical computer engineering, you can think of any kind of device you have around you, whether it's an iPhone, the technology it has in it, you have all the circuit components in it. If you have a car that is newer, you will notice that they have sensors that can guide you when you're parking, when there's something nearby, let's think about something even bigger, airplanes, all the electronic systems there that makes it very reliable. All of it is contributions of electrical and computer engineering. So if you look at the evolution of electrical computer engineering, it has really contributed a lot in many different fields, including medical imaging, computer processing. So just like to give like a brief example, if you look at computers before, like when they were first created, they were very big, okay? They were not that fast, but then they evolved to something that looks like this, right? It's still very bulky, but then now you can have a MacBook Pro or any kind of laptop that is very, very powerful. It has amazing processing power and also good resolution in terms of the screen. And all of this is contributions of electrical computer engineering. So the way I like to think about it is the two components of hardware and software and how they interact together. So let's look at your phone, for example, right? If you were a curious kid, you might have thought about opening your phone and trying to figure out the electronics in it. The same thing with televisions, remote control, anything like that. That is the hardware. You also have the other component of it, which is software. So how the computer processes information, anything related to software, like any digital system, all of it is things that you learn a lot about in electrical computer engineering. So just to give a brief example of what our areas does ECE include, I'm just going to talk briefly about it. So first we have the circuits and systems. So you have the simple circuit, for example, to turn on the lights at home. And it can be as complicated as telling Alexa to turn on the lights. And this is one of the very fundamentals of electrical engineering. You also have digital systems, which includes any system that can communicate with other systems, like you have the phone, you have the computer, dishwasher, like the new fridges as well. You also have the field of microelectronics. So rather than taking a circuit that looks like this, how do you make it look like something like this? So this is something that is very crucial of electrical computer engineering. You also have other areas such as electromagnetics, which is basically understanding how electromagnetic waves and even different types of waves that can be transmitted in transmission lines. How does that work when you have a wave propagating in the body? How do the properties change? All of this you learn about in electromagnetics. You also have computer architecture. So if you think about most computers nowadays, we use them to do multiple tasks, right? We have sometimes we have Netflix and then we're running a code on MATLAB or we're trying to browse the internet. How does the computer how does it do everything so fast? And how does it allocate memory? If you're trying to solve like a math problem on using the calculator and you're also watching Netflix, how does that happen exactly, right? How do we basically store the data? How is it more efficient, right? If you look at the previous computer I showed you, the very big one, and how now it's a very small one, all of these are advances of electrical computer engineering. There's another area which I am very interested in, which is signals and also communication. So for signals, you can think about it as the sound signal, the electric signal. It can basically be any kind of thing. When I'm talking to Alexa or Siri and I tell it to turn off the lights or play the song on Spotify, all of that is signal processing. And I will go more in depth about it later on with my research. We also have communication. So if you look at how we basically transmit signals, so you're sending a message to your friend, right? How does that message get transmitted? All of this you learn about in electrical computer engineering. You also have other newer areas that can kind of be an overlap with other majors. You have robotics, and nowadays robotics has made huge advancements. You have robots that can do multiple tasks that can basically replace humans. So you can learn more about that. We also are trying to push the current technologies to technologies that are faster and more reliable. And that includes nanoscale electronics, photonics, quantum computing. Now, this is very important when we're dealing with problems that can't be solved in a short period of time. So you have the field of astronomy and physics in general that they need to do some computations that take a long time. How can we actually do this at a faster rate? And that's the field of quantum computing, which includes developing new devices that can be way faster than the current technologies that we have. So that's the general overview of the areas we usually cover in electrical engineering. So you get a better understanding of everything, and then you're ready to take on your own project in your senior year. So this is what happens with here at the University of Rochester. We have students thinking about what they would like to do at the final year, and this is the chance to actually implement what they learned. So here are some of the really cool examples that some ECE students have done in their senior year. You have the one on the left, which is the smart home automation system. So you can basically control your phone, like the light, for example, from your phone when you're on campus. And it's kind of equivalent to Google Home, Alexa, and so on. And this is really cool because when I think about it, the general stereotype of electrical engineering is, oh, circuits, oh, computers, but you don't really think about how it actually it has advanced so much, and it's in everyday applications, you know. Another thing which was really, really cool is when during the pandemic there were a lot of problems with testing, availability of healthcare locations, test stations, and so on. So this group of students have this healthcare station that's completely how can I say that? Like, it doesn't need a person to monitor it. What it does is it has a computer that can tell you how to insert the what's it called? The nasal swab. So it guides you, and then it gets located in this area, and basically it's contact free for the healthcare worker, and then it sanitizes it as well. And this is really cool because it includes image processing, which is a form of signal processing. And it also has like the mechanics part of it. So having to control a motor, having that kind of circuit that allows you to do that. So that's, I think, very, very impressive, because in engineering, most cases, what we're doing is we're trying to find solutions to problems that we have. And I think electrical computer engineering really does give you enough of a background to tackle a lot of problems that we have. We also have another cool project, which is an autonomous robot that can deliver packages on campus. This was developed by one of the students. So what they needed to do is have the robot understand the whole map. How can it navigate, not bump into things or people. This is really cool applications, I think, of electrical computer engineering. So in terms of electrical ECE research, there's a huge variety. So it's not just circuit development, new technologies, and so on. For new technologies, for example, we have a group of researchers here who are creating this superconductive integrated circuit that is way faster, and it takes way less power than the current technology, which is very, very cool. Another cool project that one of the graduate students is doing here is BACDuet, which you might have heard of. And it basically, it uses machine learning, neural network, which you tend to learn about in electrical engineering as well. And it allows a person, to play the piano, and at the same time, you have the machine part improvising a duet with you. So this is a real-time application that is really, really cool. And this is still within electrical computer engineering. So I think this is roughly a good overview of electrical engineering.
Excellent, excellent. No, and I appreciate, because one of the things that I think that gets lost is the applications that go beyond what we immediately think. We immediately think things like instrumentation, or we think of things. We don't think about advancements in the arts with electrical and computer engineering. So I'm glad that you brought that up as an example.
Absolutely.
So,
Yeah, as I said, I think it's like more about having a creative way of looking at the world, right? If you're really interested in music, you do have the signal processing aspect of electrical engineering that would allow you to use that background to get something out of it. So there's always so much that you can do. It really depends on what you're interested in. Some people are more interested in the hardware, some interested more in the software. Well, for me, it's more medical imaging, which personally I was not really anticipating as an undergrad. Yeah.
now, in terms of your decision to be more involved with hardware and software, I mean, did you get some experience with software as an undergraduate?
Yes. So initially I came to the university with the whole purpose of doing electrical engineering and maybe minoring in economics or math or what so. And what I did first is that I did research with one of the professors, Professor Motley here, and we developed this hardware that can detect the black box of the airplane when it falls in the water. So that was more hardware. And then in my junior year of in my junior year of university, I started research at Professor Marvin Doyley's lab, which is medical imaging, and that's when I really got involved in signal processing. So I started understanding the fundamentals of medical imaging, ultrasound specifically, and how do we exactly, how can we extract information about like different biological processes using ultrasound.
So I'm glad you brought this up, because as a lot of the Full Spectrum series viewers are prospective students or parents of prospective students, I wanted to talk a little bit more about your outlook on ECE and sort of how you got here too. So let's go back to when you talked about you're in Dr. Marvin Doyley's lab. How does that process start for you in terms of being able to become part of a lab as an undergraduate?
That's a very good question. So in general, at University of Rochester, it is a research institute. So like if you want to do any kind of research, all professors are practically opening their doors with open arms, telling you if you want that research experience, you're more than welcome to do that. So with Professor Doyley, I basically emailed him, and then I bumped into him and I told him I'm interested in doing this. And the reason why is because as a child, I really wanted to do medicine, but life happened and I ended up doing electrical engineering because I enjoy circuits that was my initial decision why I chose electrical engineering. I was interested in circuits and it really fascinated me how they work and like doing the math for it. But then when I learned about medical imaging and how it's a big component of electrical computer engineering, that's what really motivated me to approach Professor Doyley and ask him to help out with the current projects, and really wanted to get a better understanding of what is the role of electrical engineering in medical imaging.
So an important note, I think, is so when you were a senior in high school, you didn't have it all figured out right away, which is a good thing. So, I mean, if you were to go back to, let's say, when you're like 16 or 17 years old, what would you think of in terms of where you are now? Like on the, you're in this process of becoming a doctor of electrical and computer engineering. Like, what would surprise 16 or 17-year-old you the most?
Definitely not doing a PhD. I think it's something that I wasn't really thinking about. I think I've talked to a lot of students who are currently doing PhDs, and a lot of them have that same perspective, I would say. You don't really understand what research is until you're at a research institute that allows you to have that experience. So I would have been shocked, honestly, if you tell me that Reem right now would be doing ultrasound imaging for monitoring cancer treatment, which is like it's not what people think of when I think about electrical and computer engineering. So definitely I would be shocked.
Well, that's good. I mean, it shows also a lot of growth in a short period of time too.
Absolutely, yeah.
So I want to talk about ECE in terms of, between the field of electrical computer engineering or medical imagery, like what is the biggest misconception? What do people have wrong the most? And what do we do to sort of dispel those ideas?
So I think the misconception about electrical computer engineering is that it's mainly hardware, circuits, and so on. However, it's actually a lot of software as well, and there's new technologies that are evolving within the hardware design. I think one thing to tackle that is to really raise awareness about current projects that are happening within the field of electrical computer engineering. How does ECE really contribute to this to the development of new technologies? Like in the beginning of this talk, I was talking to you about how electrical engineering is involved in so many different applications, including developing new technologies, right? Now, in general, if you tell someone new technologies, they won't really think about electrical computer engineering. But that's also because of the nature of research in general, is that it's very interdisciplinary. So you have physics collaborating with mechanical engineering, collaborating with electrical computer engineering. So all of this is kind of like shared knowledge that everyone contributes in. Now, in terms of medical imaging, I think the misconception of it is it being more in terms of like it's a limited field, I would say. But if you think about it, I'm just going to share my screen if that's okay. Okay. I just want to show you a misconception about ultrasound, because that's the field that I work in. Okay. So like, first of all, medical imaging is normally, as a teenager, if you ask me as a teenager, I would have thought that medical imaging and so on is not a part of electrical computer engineering. But actually, it's a part of it is signal processing, which is ECE. Now, if you think about MR, magnetic resonance, or ultrasound and so on, many people tend to think about it as an imaging tool that is just used for like seeing the baby's health and checking on like doing these checkups, right? But it actually has been evolving a lot and has been even used for diagnosing different tumors and not just diagnosing, but trying to see if a tumor is responding to therapy or not. So this is huge parts of ultrasound imaging. Another cool thing, which I find fascinating, is how much ultrasound imaging has evolved throughout the years. So this is the standard ultrasound scanner that people use when they go for checkups or so on. But in recent years, it has dynamically changed because of the hardware and the software as well. And now you can have a probe that you can just walk around with it. And this is great for remote areas where there isn't easy access to hospitals and so on. So you can really see the advancement of these technologies thanks to the current research that's being done in industry and also at universities. So imagine having a probe like this that you can just take around with you and you don't have to carry this bulky thing, right? So I think that's one misconception about medical imaging, like ultrasound imaging specifically, is that it just has one usage, but actually has been evolving a lot. And a part of the software, a part of this evolution is not just the hardware, but also the software. A big part of it is machine learning, understanding how these algorithms work, basically. And a lot of this can be done in electrical engineering or in computer science. So I think these are the main two misconceptions that I can think of.
Great. So, I wanted to think about this in terms of your thought process and problem solving. So when we talk to prospective students and even current students, we try to explain to them that engineering is problem solving, usually with like large scale math and physics applications, right? So when you approach a problem, is it primarily, okay, like how do we get an electric signal in there? Like, how do we get a receptor? Like, do you think of it just like, has your thought process of problem solving changed significantly since you started this, and how has it changed?
I think it actually has changed a lot, mainly because of the courses I took. So you can think about any kind of circuit with like a lot of practice, with like the more you've taken classes and actually spent a lot of time with, it kind of rewires your brain to thinking about problems from a different approach, right? You can think about it as like, before you might want to think about a problem, you need to like do the math, draw the diagram and so on. But when you have that muscle memory in your mind, kind of, that with practice, you actually adapt that way of thinking. So it's completely fine that when you start off, you don't really have that intuition to solve problems easily. I think the more knowledge you get, the easier it really gets to ask questions and answer these questions, right? And that's the same case for me with the whole PhD. Like I'm doing ultrasound imaging for monitoring treatment response, and I had to really understand the biology, understand the mechanics of like the wave and all that. And it's something that doesn't come easy, but with time, you really do learn how to think about these things more. So it's kind of like a muscle memory, I would say.
I do like that you use the term rewire your brain. I mean, it does fit in your
Yes,
field.
it does.
So
It really does.
I just a couple more quick questions. I wanted to ask you about being a PhD candidate. What are some of the highlights and what are some of the difficulties in being a PhD candidate? Because we know that it is such a dedication to your field. But can you tell me a little bit what it's like right now?
Okay. So I'm going to talk to you about how it was in the beginning
Okay,
versus
good.
now, because I think it's something that I learned with time.
Mhm.
So in the beginning, a lot of like I thought it's going to be more similar to undergrad and masters, in which like you're assigned a problem and you really think about it and solve the problem. Now in the PhD process, it's actually a bit different. You have a general like project that you're working on, but it's a lot of reading, trial and error, failing multiple times and failing again and again until you finally answer your question. And it really does put a lot of pressure on you because like in most research, you're asking a question that no one else has asked, right? So it's really leaving your comfort zone and challenging the way you think, and also, of course, approaching others for help and so on. So I think one of the hardest things about the PhD is that a lot of the times it's interdisciplinary. How do you say it?
That's correct.
Interdisciplinary, yeah. So you would really need to put more thought into it. It's not a simple problem like a homework problem. It's actually more complex than that. And in general, another challenge of it is kind of having like a plan, right? So you kind of always need to think about the long term. What is your goal? What are you trying to answer? The big question, and right, and then thinking about how can you answer that question. And it's a lot of time spent debugging and also reading up on what kind of approach that you can take. But I think that's also the good part of it is that it's such an open field that you can ask this question but get to the answer in so many different ways. So yeah, it really does give you that flexibility of like thinking about the problem in different ways, testing things out. And I really think it's dependent on the kind of research you do. So if you're doing it in integrated circuits, it's going to be, I think, very different from ultrasound imaging. Does that answer your question?
Yes, definitely, definitely. My last question is, so in my heart, I will always be an advisor, and I know you are a peer advisor, so I like hearing other people's advice. So what advice do you have for younger people who are interested in electrical computer engineering? Like, what's something they could do today to get to a better understanding if this is something they want to do?
That's a very good question. So I think it's important for the student to know what they're comfortable with. Like, are they interested more in the hardware side? Are they interested more in the software side? And I think it's okay. The big thing actually is to try to get a better understanding of everything. So with today, you can actually buy an Arduino, you can program it to do different things. And I think that's a very great project. Like it's one of the things that students tend to do in their first year of electrical engineering, understanding how to code. And I think there are great kits on you can buy on Amazon and so on that can allow you to create these circuits. I think learning different programming languages is also a very good thing, even though it could be challenging in the beginning. But I think it would make it easier within electrical pure engineering.
Excellent. Reem?
And also another thing, it's okay to not know what you want to do. I think what's important is like to look online at different projects, see if there's something that interests you. Like if you're really interested in music, you can definitely do a lot of things within music, and that's there's a whole field in University of Rochester, audio and music engineering that really goes in depth into it. And it's a part of ECE. So I think it's important to it's good to not have a great understanding of what you want to do, but also it's good to not to limit yourself to one thing. Like if you're really interested in software, it's really good to have a better understanding of the hardware, because sometimes you have an idea, you want to implement a new device, or you want to try out something different, like the senior design projects, for example. And it's really good to have that foundation. And as I said, there's like a lot of resources online that show you how to create these different devices and also how to code and so on.
Excellent. No, that's wonderful
Yeah.
advice. And it is one that we would like to share always with the students coming in, that you have time to figure this out.
Absolutely. Absolutely. I think at the university, it's really good to, okay, so here you can do electrical engineering, mechanical engineering, biomedical engineering. I think it's important to know if you're like interested more in like the mechanics side, that it's good to, I think it's good to have initial like a kind of aim, something that you're interested in, but it's actually way more complex. And it's not way more complex. Like there's a lot of things that you can do within every field. So if you're really interested in biology, electrical engineering can be good, biomedical engineering can be good, and you never know how your degree can really contribute. Like if you ask me and you tell me medical imaging, I would not, I wouldn't have expected I'd be doing medical imaging right now as a part of ECE. So I think that's really like that tells you something about this field.
Excellent. Well, Reem, future Dr. Mislati, thank you for your insight and spending time with us. We really
Of
appreciate it.
course.
The Full Spectrum series is now online with other areas such as biomedical, chemical, optical engineering, and more. Please check the Hajim School Facebook, Instagram, and YouTube channel for more. And please feel free to share this video on behalf of the Hajim School. Thank you for watching, and we hope to see you soon.